think y'all are upset. Yeah, the school clocks think it's 10:48. Yeah. But that also means that hurts y'all on the front end, because that means that you're actually, the first bell is ringing instead of at 10 or at 7:50, they're actually ringing at 7:48. So, well, looking back to this here, we're looking at addition and subtraction today. Now, addition and subtraction isn't too bad as long as the denominators are the same, because if the denominators are the same, we can go on and add or subtract the numerators. Well, here, since both of the denominators are x minus 5, we can go on and just add the numerators together. Well, we can add the 6 and 2, which would give us 8, and the x doesn't have a like term. Since the x doesn't have a like term, we would just have x, and well, the 2 and 6 would give us 8. Now with the plus, the x and 8 are really stuck together. They're a single term. In the denominator, the x minus 5 is a single term. So we're not able to simplify the x and x out here. We would need it to both be either be x plus 8 or the top and bottom to both be x minus 5. And there's no way that we can factor x and 8 because they don't have any like terms or terms in common. So it actually works out that there is the final answer. So we don't have to do anything to it. And one of the biggest things I will say with addition, subtraction, especially our complex fractions, we need to simplify all the way down before we start trying to cancel anything out on top and bottom. Any questions on this here before we move on to the next one? Let's look at the next one. Well, again, they already gave us the denominators as the exact same thing, which is nice because that means we can add the numerators together. And the denominator is going to stay x plus 5 times x minus 2. And we can add the numerators. Well, x squared and is just going to be x squared because in both denominators, x squared is the only like term for x squared. Now we can do 3x plus 4x, which would be plus 7x. And lastly, negative 2 plus 12 is plus 10. Now, most likely, x squared plus 7x plus 10 will factor. And if we factored this numerator, what are we hoping we get? Well, I'm either hoping to get what, an x plus 5 or an x minus 2, because if I get one of those, we can simplify with top and bottom. Well, since the 10 is positive, we know the signs are the same, and they're both going to be positive. Well, that kind of tells me one of those is not going to be what? X minus 2, yeah, because if they're both positive, there's no way it can magically become negative. Well, the factors of x squared are, and the factors of 10 that we want are 5 and 2. And the x plus 5 times x minus 2 will get us back to the x squared plus 7x plus 10. Well, we do have something in common on top and bottom. The x plus 5 and x plus 5. Which leaves us with x plus 2 over x minus 2. Well, again, x plus 2 is a single term, and our x minus 2 is a single term. And it's a good way to think about these just so we don't want to try to cancel out the x and x or the 2 and 2. Now, if we look at the numerator x plus 2, is there any greatest common factor we can pull out? Well, no. And neither is there in the x minus 2. Now, there was one problem, or a few problems that we did the first time we came through this where we were able to pull out a negative and get them to be the same. But we would only want to do that if both terms were opposite signs. If both of the terms were opposite signs, then we could pull that negative out. But if we look at the x's, they're both positive. They have the same sign. And the 2's are opposite. So if I had pulled a negative out of the numerator, it would have given me negative x minus 2. Well, that's not the same on top and bottom, so it doesn't work. So the only time we'd really want to try to pull a negative out to get them to be the same is if both signs were opposite. So in the numerator, if it had been negative x plus 2, then we could have pulled a negative out and they would be the same. But here, that's as far as it goes. We can't do anything else to it. Any questions on this here? Be ready for the next one. Now, when we look at this one here, the denominators are x squared plus 7x plus 12. So there's a good chance we might need to factor these to see if there is a greatest common factor, not greatest common factor, but if there is something in common on top and bottom, that will reduce, like the last problem had. But are both denominators the exact same? Well, yeah. So we can actually go on subtract and then worry about factoring the denominator later. Because at this point here, since the denominators are already the same, we don't have to do much to actually do the subtraction. Now the first numerator, our x squared minus 2x plus 3, there's nothing going to happen with the signs because we're not actually subtracting it. But our second one, the x squared minus 4x plus 5, is being subtracted from the first, yes? So that means we'll have a negative x squared. And the 4x would be plus 4x, because we're subtracting a negative 4x. When we subtract the negative and negative make a positive. And when we subtract negative 5, the negative and negative make a positive. And the denominator is still going to be x squared plus 7x plus 12. Any questions on this here? Now at this point here, we can go on and subtract the like terms in the numerator. Well, the first thing we have is x squared and negative x squared, which is 0. X squared minus x squared is 0. They cancel each other out. Now the next one we have is negative 2x plus 4x, which would give us a positive 2x. And lastly, 3 plus 5 is plus 8. And this is over our x squared plus 7x plus 12. Now again, before we say that this is the final answer, we do need to make sure that there's nothing in common on top and bottom. And we can do that by doing some factoring. I do see the numerator, the 2x and 8 do have a greatest common factor of 2. So I can factor 2 out of both the 2x and 8. When we factor 2 out of 2x, or we divide 2x by 2, we're left with x plus 8 divided by 2 is 4, yes? Well, doing that kind of gives us a good indication that there might be something in common on top and bottom. Because is 4 a factor of 12? Well, yes, and x is a factor of x squared. So, okay, so there's a good chance that we might end up with an x plus 4 as one of the factors. So let's go on and factor the x squared plus 7x plus 12. So we'd have two sets of parentheses. Since the 12 is positive, the signs would be the same and match the middle term, which would be plus and plus. The factors of x squared are going to be x and x. And incidentally, the factors of 12 we want are 3 and 4. This 3 plus 4 would give us our middle term of 7x. And before we simplify, are there any questions on how we got to this point? Well, we do have something in common on top and bottom. So the x plus 4 and x plus 4 would cancel, leaving us with what? 2 over x plus 3. And that'd be it. And with all of these here, one of the biggest things that we need to do is wait to the very end to start canceling out things on top and bottom. It's going to be very tempting, especially in some of the ones that we'll look at, to try to cancel things out, but we have to wait till the end for us to be able to do it. Any questions on this here? All right. Let's look at this one here. Lock in place. Okay. I just wanted to move it over so that we have a little bit of room, because this time, unlike the last one, the denominators are not the same. But I need to get them to be the same using least common denominator, which is actually the least common multiple we did yesterday. But what are we trying to get to be the same? The denominators. So that's why they call it least common denominator. And when we look at these two, x squared and 7x, we want them to be the same. Now the one on the left has an x squared. The one on the right has an x. So how many x's do we need for both of them? 2. We need them both to be x squared, yes? Well, with the x squared, do I need to do anything to get it to be x squared? Well, no, it's already there. But the one on the right, the x, I need another one, yes? So to get it to be x squared, we can multiply it by x, because x times x gives us x squared. It's missing 1. Okay? So we have the variables all the same. But the one on the right also has a 7. The one on the left doesn't have any number besides 1. So I need to multiply the one on the left by 7 so that they are the same. Now, will doing that get the denominators to be the same? Well, yeah. And if we multiply the numerator, 7 times 2, we get 14 over 7x squared minus, for the other numerator, 3 times x gives us 3x. The denominator would be 7x squared. Now, again, at this point here, it is tempting to say we could simplify, because on the left we do have 14 over 7, yes? But on the right we do have the x over x squared. But for us to be able to add or subtract, we need the denominators to be the same. And if we had simplified here, well, we'd actually get back where we started, so then we couldn't actually add or subtract. So with addition and subtraction, we've got to wait to the end before we do any simplification. So since the denominators here are the same, we can go on and subtract the numerators. The denominator will stay 7x squared. The numerators will be 14 minus 3x, or we can say negative 3x plus 14. Either one works out just fine. Now, before we can say we're done, do the 14 and negative 3x have any greatest common factors? Well, no, because 14 and 3 don't have any greatest common factors. Both of them don't have an x. So that there is as simplified as it gets. And that's all we have to do for this here. Any questions on this here? All right, let's look at this one here. Lock in place. So here we need the denominators to be the exact same. Yes, so we're going to have to multiply both of them by something on top and bottom to get there. Do y'all want to look at the variables or the numbers first? Because we'll have to look at both. Which one do y'all want to do first? The numbers. So we're trying to see what is the smallest number that we can turn 18 and 27 both into. Now we can do it like we've been doing previously, where we do 18, all the multiples of 18, all the multiples of 27 to see where they match up first. Well, now what we can do is we can actually use the graphing calculator. Now the reason I cleared it out is so it doesn't actually give us the answer. I forgot to do that after last hour. To pull up least common multiple, what we can do is hit math and go over to number. Too far. And go to LCM, least common multiple, and hit enter. And we're looking at, because I know it was 27 and 18. So we can say 18 comma 27. The bigger number doesn't have to go second. We could have said 27 comma 18. Both of those would have worked. And if we hit enter, it tells us that it's 54. And if you like doing the multiples better, that's perfectly fine. It's finding out which way works best for you. So what we need to do is turn both 18 and 27 into 54. So we can look at 27 first. Well, what times 27 is 54? 2. So we're going to end up multiplying top and bottom by 2 so they become the same. Now we need to see what times 18 is 54. 3. So we multiply top and bottom by 3. So okay, we've got the numbers squared away. Now we need to get the variables. Well, we can look at x first. So on the left-hand side, we have x to the third. On the right, we have x squared. So x to the third we're not going to mess with, but we're going to bring x squared up to x to the third by multiplying it by x. We need one more because it has 2, but we need 3. So we can multiply it because x squared times x would give us x to the third. Now we can look at the y's. Well, we have y and y cubed, so we'll need to multiply the one on the right, or sorry, the one on the left by y squared. Because we have one of them and we need 3, so we multiply by y squared. Now the denominators will be the exact same. And both of them are going to be 54 x cubed y cubed. Now the numerator for the one on the right, we're doing 3y squared times 1, which is just 3y squared. Now on the one on the left, we have 5 times 2x, and 5 times 2x is x. Now that we have this here, we can go on and add these numerators together. Well, is 3y squared and 10x like terms? No, so we can't combine them. They just give us 3y squared plus 10x over 54x cubed y cubed. Okay. What would we do next? Huh? Right, we need to find more, it'd be greatest common factor because we're trying to see at the top what we can pull out, if we can pull out or factor it. Is there a greatest common factor between 3y squared and 10x? Well, no. Is there a number that goes into 3 and 10? No. And they both don't have the same variable, so our next step is to circle it. We're done. Because this won't simplify any further. Because the only way we can simplify this is if 3y squared and 10x had a common factor. But there's not one. And we would need a third term on top with, we would need the 10 to have x and y and then have an x squared for us to possibly be able to factor. But this is as far as we can go with this here. Any questions on this one here? Be ready for the next one. Now, this one here, again, I'm going to go back and edit all these because I want a little more space. Unlock. There we go. Lock in place. These here, when we have these terms of like x and x plus 3, I like working with these a little bit better because it's easier to figure out what's going to make them be the same. Now the one on the right is missing a what? X. And the one on the left is missing in x plus 3. Because we can consider all of these, or the x plus 3, as a single term. The x is a single term. Because on the previous one, we were trying to get one term to be the same with our numbers and variables. Here it's a little bit easier to work with. Now we can multiply them because we do have the same denominators. The one on the right is going to be x times x plus 3. And the other denominator is going to be x times x plus 3. Now, probably I'm wondering why we don't multiply out the x times x plus 3 and get x squared plus 3x. Is because if in the numerator we end up with an x plus 3 by itself in factors, well, then we'd have to factor it back out. Or if we're left with just an x on top that we can simplify, then we'd have to factor it back out to x times x minus 3. So we leave it as this here, because we don't have any addition or subtraction going on in the denominator, but we do in the numerator. All right. So the next thing we can do is multiply the x plus 3 by 5. Now I did bring this up in the other hour, but it's probably y'all noticed that some of the numerators I will multiply them out and some I won't until we do it a step later. And that's purely because here, do we feel comfortable with doing 5 times x plus 3 without kind of losing signs or having anything kind of go a little awry? Well, I do. I mean, I think y'all do, yes? Doing 5 times x is 5x. 5 times 3 is going to be plus 15. Because if I feel comfortable doing that multiplication right there, I'll go on and do it. If I don't, and I feel like there's a chance I'll mix up the signs or mix up some of the terms, I'll go on and just write it out with them multiplied in their parentheses, and then do that the next step. Here, on the other side, 7y times x would give us 7xy. So again, if that's not too bad, we can do that pretty easily without having to worry about too many complications coming up. And now, because the denominators are the same, we can go on and subtract the numerators. Well, do we have any like terms? Well, no. And what we're subtracting, the numerator for what we're subtracting is a single term, yes? So I don't feel too uncomfortable saying 5x plus 15 minus 7xy. So we can combine those pretty easily. We don't have 3 or 4 terms where we have a lot of sign changes. So it's not too bad to just stick it like that. That there is actually our answer. So a lot of steps that you could skip. There are steps that we do in here that when I go through the lesson and we go through the example problems that you could skip, but I would only kind of skip them or combine steps if you feel comfortable enough to be able to do it without mixing signs or dropping numbers. Now let's look at this one here. Well, we can see that the denominators aren't the same, but we're not going to be able to just multiply the left one, the 3x squared minus 6x, by the x squared minus 4x plus 4. And we shouldn't just jump ahead and say that x squared minus 4x plus 4 needs to be multiplied by the 3x squared minus 6x. Because if there is a common factor that they share, we would be adding an extra one in. We'd be having more factors than what we need. So before we do any of that, the first thing that'll be helpful to do is to factor both denominators. Because once we factor both of the denominators, we'll be able to see what we actually need. Now for the first one, 3x squared and 6x do have a greatest common factor of 3x. Now if we factor the 3x out of 3x squared, we'd be left with x. Because really we're dividing by 3x, and 3x squared divided by 3x. The 3 over 3 would simplify. X squared over x would leave us with x minus 2. Because our 6 divided by 3 would be 2, and the x would simplify out completely. So for the first one, we have 3x times x minus 2. Now we need to factor the x squared minus 4x plus 4. Because the 4 is positive, our signs are the same, and they match the sign of the middle term, which would be negative and negative. Now the factors of x squared are x and x. And the factors of 4 that we want would be 2 and 2. Because with both the signs being negative, if we use 1 and 4, we'd actually get a middle term of 5. So, looking at this here, we now can better see what we need to multiply both of the denominators by to get them to be the same. Now, what does the right one have that the left one doesn't? So the left one is missing an x minus 2 because the right one has 2 of them. So the left one, I need to multiply top and bottom by x minus 2 over x minus 2. Apparently I'm a little too far over. Or too close to this here. Nope, just too far over. All right, that's fine. Now the one on the right, what is it missing? 3x. So we'll have to multiply top and bottom by 3x. Now if we do the multiplication here, The one on the left, we're going to do 7 times the x minus 2. And if we do feel comfortable with multiplying it at this point, we can go on and do that. Well, 7 times x would be 7x. 7 times our negative 2 would be negative 14 over 3x times x minus 2 times x minus 2. Yes, we can actually go on and do that. Almost, it's probably going to take out the whole thing. That's fine. We could say x minus 2 squared plus. On the left-hand, right-hand side, we have 3x times x minus 2 squared in the denominator. In the numerator, we'll do the x squared times 3x, which would give us 3x cubed. And last but not least, we'll need to add these together. Well, 3x cubed, 7x, and negative 14, none of those are like terms. So we'll end up getting 3x cubed plus 7x minus 14 over 3x times x minus 2 squared. Is there any like terms in the numerator with 3x squared, 7x, and negative 14? Well, no. If we wanted to factor by grouping, if you remember back to our pretty much greatest common factor twice, where we split them into 2 pairs, factored out a greatest common factor, and then did it again, we would actually need 4 terms. We'd need 4 terms to be able to do that. And there's not anything we can do with the 3x cubed plus 7x minus 14 to factor unless we kind of knew what one of the factors were and worked backwards to get to it. So it actually works out that this here is the final answer. Now, one thing I would be careful with, especially with the x minus 2 squared, is if there was an x minus 2 in the numerator, when you simplified the one out, you don't simplify this one here out completely because there are 2 of them. Because if there's just one on top, it would simplify the square to the first power. So that's something to be careful of. But this here is the answer because there isn't an x minus 2 on top, so this is as far as we can go. Any questions on this here? Well, this here really doesn't add anything. Are there any questions on how we do any of these here? Okay. This one here is, I think, the only one that could add something to it, but we're running a little short on time, and it's not really going to make a huge impact because I don't think we'll have anything like that on the, no, we won't have something like this on the test, and nothing like this on the homework. So are there any questions on anything we've done so far? Hopefully this is helping you all to get a better understanding of it.